Hello everyone. In order for a power system to be stable, it is important that the power generation and power consumption are in balance at all times. In this lecture, we will focus on the demand side by looking at different kinds of loads. An electrical load is a component of or part of the circuit that consumes electric power. Electricity can be converted into many other energy forms. For example, it can be transformed into energy forms that can be directly used by the consumers, like light, heat, and mechanical energy. A load curve or load profile shows the variation in electrical load or demand. This variation is shown for a specific time frame. For example, a day. This information is relevant for generation companies and system operators, as the generation output of the controllable generation units will depend on the forecasted and actual demand. A power balance between generation and demand should be kept at all times. To keep the system stable, let's have a look at some important types of loads. One of the main loads is lighting. Major changes have occurred during the past years in order to make lamps more efficient. The incandescent lamp has a relatively low efficiency and has been replaced by fluorescent lamps and LED lights during the past years. Let's focus on the different types of lamps for a moment. The incandescent lamp is the oldest type of lamps. It consists of a thin filament that conducts electricity. When switched on, the current heats the thin filament and radiates light. To prevent oxidation, the filament is inside a glass bulb filled with an inert gas. This load is a purely resistive load, therefore, it only consumes active power. The halogen lamp followed the incandescent lamp. The housing of the halogen lamp is filled with the halogen gas. The halogen gas reacts with the evaporated metal and redeposits it on the filament as a self repair mechanism. The filament temperature can be higher than in case of an incandescent lamp, and this results in higher luminosity. The fluorescent lamp came afterwards, and it is in the main source of lighting today. In this case, electrons collide with mercury ions, resulting in ultraviolet radiation. A ballast, which is an inductor, is required to limit the current flow. One drawback of fluorescent lamps is that they consume considerable amounts of reactive power, as opposed to incandescent lamps, which only consume active power. The light emitting diode, LED or LED, is a semiconductor that emits light when current passes through it. LED lamps have a low energy consumption and long lifetime. The main drawback of LED lamps is their effect on the power quality, as they produce distortion in the AC waveform. Now that we have covered some important light loads, let's have a look at the heat loads. In a heat load, electricity is mostly converted directly into heat by a resistor. Some examples are a boiler, a water cooker, the electric stove, and aluminum and steel furnaces. When the load is fully resistive, it doesn't consume reactive power. Mechanical loads have an important participation in the demand curve. The conversion from electrical energy to mechanical energy is done by motors. The first motors that were developed were operating with direct current. Some examples of direct current motors are electric trains and hard disk drives in computers. Nowadays, there are many motors operating in alternating current. Motors are inductive components, and as a consequence, they consume reactive power. Loads can be classified into residential, commercial, and industrial loads. Residential loads are connected to the distribution system. The common voltage ratings of distribution systems are 7.2, 10, 11, and 12 kilovolts. Distribution transformers are used to bring power down to lower levels, for example, from 10 kilovolts to 400 volts. Residential loads are in general single-phase loads. In the figure you can see there are phases denoted as A, B, and C. In order to keep the three-phase distribution system as balanced as possible, houses are connected to different phases. Please notice, for example, that the house on the top left is connected between phase A and the neutral, whereas the house on the top right is connected between phase B and the neutral. Commercial and industrial loads are generally connected at the distribution level, ranging from 10 to 72.5 kilovolts, or at the transmission level, ranging from 110 to 150 kilovolts. In many cases, the public utility brings underground cables or overhead lines to the premises of the company. The company generally owns the medium and the low voltage transformers required to bring the levels to the ones required by the loads. Some large industries not only consume electricity but also produce electricity, for example, by means of large combined heat and power units. With the adoption of distribution generation, residential consumers are now turning into prosumers, or in other words, consumers that also produce electricity. In the coming years, larger loads are going to be connected at the distribution level. For example, electric vehicles, batteries of different sizes will also play a bigger role in distribution systems. In order to keep the power balance of the system in the future, loads will most likely be involved in mechanisms such as demand response. With such a mechanism, the loads will react to incentives and allow a shift in their operation according to the needs of the power system. For example, the time of use of a washing machine can be shifted to that so that it matches a time period in which there is a higher production of electricity, like when the sun is shining. Today, you learned about different kinds of loads. You also learned about some changes that will occur in the power systems with respect to loads. Namely, some loads will become bidirectional, some large loads will be connected to the distribution system, and some loads will become controllable and participate in demand response mechanisms. Would you allow an external party to control when to switch on your devices at home?